What's going on, everybody? Moving on with Chapter 5, Lesson 5.5, Triangle Congruence Theorems. Just a reminder, you can go into Canvas. All right, here on the homepage, you can find all of the notes and the PowerPoint slides that go along with it for 5.5. Okay, so triangle congruence, there are multiple different theorems that can prove if two separate triangles are congruent to each other. Just a reminder, congruent means same size and same shape. Okay, included side or angle. Included, the word included is the geometric way of saying in between. So if it's an included side, it's the side in between two specific angles. As you can see right here, there's two angles and the included side is the in-between side of those two angles. And the same thing for the included angle. The included angle is the angle in between two sides. So you have side AB and side BC. It creates angle B. So that is an included angle. Okay, now getting into all of the different theorems that prove if whether or not two triangles will be congruent to each other. SSS, or side, side, side. If three sides from one triangle are congruent to three sides of the second triangle, then they are congruent, right? You don't need to necessarily know that the three angles are congruent to each other, because if they're the same exact three sides, it will automatically be that way. Okay, side angle side, or SAS, if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then those triangles are congruent. So this is super important that it has to be the included angle, right? SAS. The way that I always like to describe this is that if you go in order, right? If you were to have your pencil on this triangle and drag it, you cannot pick your pencil up. You hit the side first, then the angle, then the side. Side first, then the angle, then the side. They both have to be in that same exact order. Okay, angle, side, angle. Now it's just the opposite. But again, it has to be in this specific order. If two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, the triangles are congruent. And again, if you have your pencil on the page, you cannot lift your pencil up. You see that you hit the angle first, then the side, then the angle, then the side, then the angle. Remember, the congruency marks tell you which ones are congruent to each other. One bubble matches one bubble, one line mark matches one line mark, two bubbles match two bubbles. Okay, angle, side. If two angles and the now not included side of the triangle is congruent to two angles and the not included side of another triangle, then those are congruent. And once again, if you just keep your pencil on the paper and do not ever lift it up, you see that you see angle, then the angle, then the side. Okay, then you go angle, then the angle, then the side. You technically cannot go, so if I use a different color, right, you can say, well, what if you go this way, right? And let's not erase that. Let's erase just one of the triangles. Okay, what if you go, well, now if you go this way, now you have angle, side, angle, right? But notice there's nothing over here. There's no congruent angle. There's no marks to say congruent side. So you cannot go in that direction, right? You have to go with what comes next. If you're starting here at this angle C, for example, going this way, you don't hit anything. Going this way, you will hit that congruent angle. Okay, so that's how you can tell of which you have to go a specific direction. Okay, hypotenuse, leg. Hypotenuse and leg of a right triangle. So hypotenuse, leg, or HL only happens when you're dealing with right triangles. If the hypotenuse and leg of a right triangle are congruent to the hypotenuse and leg of another right triangle, then the triangles are congruent. Okay, so we haven't talked about what a hypotenuse is. It's going to be on the next slide. Okay, you will find out here. Let's just do this first. The hypotenuse is the longest side in a right triangle. It is always opposite from the right angle. So again, this theme of opposite comes up a lot, right? We see the right triangle. Opposite means away. Always draw an arrow away. You are now pointing at the hypotenuse of a right triangle, which will always be the longest side in a right triangle. So let's go back to our definition of hypotenuse, leg. All right, we see that the hypotenuse, which is always opposite from our right angle, has two congruence lines. Both of these hypotenuse are congruent to each other, and a different leg is congruent to each other as well. Okay, there is no ASS in geometry. It does not work. There is a YouTube video here. I will put this video in the or not in the comment section, in the description section. So that way you can click on this link. It'll take you to another video. It shows pretty well of why ASS, or angle side side, will not absolutely prove congruency. Okay, so make sure you watch that video as well. Okay, so when using these theorems, it's important to make sure you count and name them in order. Okay, also remember, think back to lesson 5.1. I know it was during first semester, but we talked about corresponding. Whenever you name triangles that are congruent to each other, you have to name the corresponding angles and sides in the correct order. All right, so if we were to look at this example here, again, find them that match. We see one congruency mark starts here, so that is a side. If I go along, I've now hit a congruent angle, and if I keep going, now I've hit a congruent side, and we see that it matches. We have side, then we hit the angle, then we hit the side. So these two, we can prove that these two triangles are congruent to each other based off of SAS, or the side angle side theorem. And then if we wanted to say that they are congruent to each other, the order matters. Remember, if we say a triangle ABC, we have A, B, C, we have to name this triangle in this exact same order. We see that A is on top, D is on top, B is the congruent angle, E is the congruent angle, C goes last, so F goes last. And we could, ABC doesn't have to be the order, but if we change this order, that means we have to change this order. So for example, we could technically also say triangle BCA, all right, just threw out some letters. So since we put B first, we would say that it is congruent to triangle. Now, since we put B first, we have to put E first. That's a bad E, but I promise that's an E. C came second, so we have to put F second. A went last, so now we have to put D last. So now you can also say triangle BCA is congruent to triangle EFD. The order is important and it matters. Okay, so here's some examples. Again, identify which theorem proves that the two triangles are congruent. Label which sides and angles are congruent with either an A or an S. All right, so we see that two bubbles matches two bubbles. We know that's an angle, so we have angle. All right, now we have another bubble matching another bubble. That's an angle, and then we have a side here, side here. And again, if we go in order, we have A, S, A, S. They match. So these are congruent by the angle side theorem. And if I wanted to say that these two triangles were congruent, again, the order matters. Let's call this one triangle CBA. Has to be congruent to the letters have to match up. So since we put C first, Z has to go first, B goes second, then that means Y has to go second. A goes last, that means X has to go last. Okay, so this one's fairly easy because the triangles look literally exactly the same. Well, if we look over here at this one, we notice that the triangles are actually rotated a bit. They're not in the exact same orientation, but you can still find that it still works. Again, so we have an angle here that matches this angle. We have a side here that matches this side, and now we have another angle here that matches this angle. And again, if you have to go in order, right? We start with an angle, then you get a side, then you get an angle. So that one is ASA. But let's see if it matches. We again see angle, side, angle. So that's good. We again see that we have ASA. Okay, and if we wanted to give a congruency statement, then it doesn't matter the order of the first one, but you have to make sure that the second one matches. So let's do this one first, just because why not? And let's say we use PQR. Now we say that that is congruent to triangle. Since we put P first, that means we have to put A first because that's the corresponding. Since we put Q, that matches with B, and R went last, so that means C goes last. Okay, there you go. There's those examples. Some more. All right, again, label with S or S for side, A for angle. We see that 2 matches 2. Those are sides. 1 matches 1. Those are sides. And these ones match here. Those are angles. Now, again, count in order. We see that we have side, angle, side. Let's see if it matches. We do, in fact, have side, angle, side. So these are congruent due to the SAS theorem, or side, angle, side. And then if we, again, making a congruency statement, let's go triangle A. That's a bad A, D. That's a bad D, K. That's an okay K. So at least 1 out of 3 is congruent to triangle. A is over here, so that matches with T. D is up top, which matches with S, and K matches with K. So triangle ADK is congruent to triangle TSK. Okay, now over here, right, we are given an angle. We are given a side, we're given an angle, we're given a side. Those are all the congruency marks that we have here, though, right? But what we can see is that this line segment, WL, notice WL is a part of this triangle and it's a part of this triangle. And since it's the same exact line for 2 different triangles, even though we weren't given a congruency mark, right, we know for a fact that this line is congruent because it's the same line. It's going to be congruent to itself. Right? So now we would say, okay, now this is a congruent side. Even though it's not given to us in the beginning, we can still deduct and conclude that this is a congruent side. So now we count. We have angle, side, side. Matches with angle, side, side. So this one comes out to angle, side, side. But remember what we had said earlier. ASS does not automatically prove or automatically conclude that 2 triangles are congruent. Even though if we look at this, like looking at it, it totally looks like they would be the same exact triangle. But ASS cannot 100% conclude, right? So this one, we would say that it is not congruent because we would say that we need more info. And I'm not going to write all that, but you would need more information to absolutely 100% conclude that it was, in fact, 2 congruent triangles. We don't have enough to prove it, even though they look like it. Okay, here, right triangle. Your right triangle should automatically register in your mind and make you think like, ooh, let's automatically check hypotenuse leg first. So remember, find out what your hypotenuse is. Always draw an arrow away from your right angle. We notice that there's your hypotenuse there, right? And we see hypotenuse of both triangles are congruent to each other. So we know we have the H, but remember we need to know that a hypotenuse and a leg are congruent. Okay, if we take a look at this leg and this, here, let's use a different color. If we take a look at this leg and this leg, nothing tells us that it's congruent. There's no congruency marks. There's no numbers. There's nothing like that. So that doesn't help us, right? And then if we use a different color, however, NO, it's that same situation, right? NO is a part of this triangle and NO is a part of this triangle. So since it's the exact same line for 2 different triangles, even though there's not a congruency mark on it, we know for a fact that it is a congruent line because it's the same line. So now we can automatically conclude that this one, and there's our leg. So now we would say that this one is congruent based off of the hypotenuse leg theorem. And again, congruency statement, you've had 4 examples of those, so I'm not going to do another one. Over here, side matches a side, 2 marks side, 2 marks side. Again, nothing else. No angles have been told to us that they are congruent. But again, HJ, this segment right here in the middle, HJ is a shared line. HJ is a part of this triangle and HJ is a part of that triangle. Since it's the same line for 2 different triangles, we automatically conclude that that is congruent to each other. Excuse me. So now we can say that those are congruent, and now we have SSS. And again, congruency statement, we'll do last one. Last one, why not? Triangle HKJ is congruent to triangle H. K went second, so that means I goes second, and J goes last again. HKJ is congruent to HIJ. And that's all I have. Those are the 5 different congruency theorems. I went through it really quick, just trying to make these videos shorter in order for you guys to have an easier time watching them. Please bring any questions into class. We'll go over it together. Have a great day. Go Mustangs.